Hello, very good afternoon, everyone. I hope that I am audible as well as visible to you all. Very good afternoon, everyone. And there is a doubt by Sri Karthik S. Hi, sir. I have doubt. In my email, there was 3 sessions. Should I attend any one? Yes, you can attend any one, or you can attend all of the 3 sessions. Depends truly on you. Okay. Each person will be teaching the content as well as the examples in his or her style. So it truly depends on you. Okay. Whichever way you feel comfortable. Okay. And you find that the content is knowledgeable, you can attend the session as well as clear your doubts. The main idea is to clear your doubts from any of us. Okay. This is the main idea. In the starting, I will just switch off the setting to turn on the mic because a lot of students are joining and leaving at the same time. Okay. Yes, we shall just start in 5 minutes. Okay. The basic idea is to clear your doubts. Okay. So in any of the session you can attend. Okay. Or if you want to attend all the 3 sessions, you are having time and effort to do so, then you can do that as well. Okay. Yes. But get your doubts cleared. That is the main idea. Okay. You should not, at the end, you should not be in a dilemma that how this particular question was solved. Okay. So that is my thing to say. Okay. Get your everything solved. Seconds. Hello, very good afternoon, everyone. Could you please confirm once that you can see me, you can hear me as well as you can see the slides? Okay, very good. Thank you so much. We will just start in few minutes. Actually, a lot of students are joining and leaving. That is why I am waiting for some stability. After that, we will just start. Okay. Okay, my dear students, we shall start. Okay. I hope that there is no problem in the audio, video, and everything is fine. Okay. Let us start. So, very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session, this particular live interactive session on the course Computer Vision. And this course is taught by Professor Jayant Mukhopadhyay from IIT Kharagpur. And what I will be doing in this particular session will that will be solving some of the questions based on the previous week's content. Okay, whatever has been taught in the previous week, we will be solving some of the objective questions as well as multiple choice questions or multiple select questions based on the previous week's content. Okay, in this particular session, I'll be walking you through, and what you have to do, you have to just take a pen and paper or a notebook along with you and try to solve along with me. Okay, this is the thing. So the very first question that I want you to solve, you just try to solve it. Okay. Consider the following 5 by 5 image array to answer this particular question. Okay. An image array has been given to you. Okay. And you have been asked what is the value after histogram equalization at location 3 comma 2. Okay. In case of matrices in computer science, the indexes always starts from 0. Okay. That is why if you will see in this particular case, the indexing is row by column. Okay. So you try to see that row number 0 is this one, 3364. Okay. Row number 1 is 22004. Row number 2 is 12405 and row number 3 is 51321. Okay. So row number is 3 and column number is similarly 0, 1 and 2. So the element 3 that has been marked as star is 3 comma 2 in terms of computer science. Okay. So you try to solve what would be the value after histogram equalization at this particular location. Okay. Then try. Okay. Then after a few minutes, I'll walk you through how to solve this particular question step by step. Okay. This is the thing. Sir, your pointer is not showing on screen. Okay. See, I am not you particularly using pointer on the screen. I am displaying the slides. Whenever I will be writing some of the thing using my stylus, then you will be able to see. Okay, don't worry about that. Okay, I am monitoring everything. Okay, from three different devices. Don't worry. If any issue is there, I'll try to resolve. Okay, you just try to solve. Okay, yes. And one more important thing in this particular session, there is no need to be very much formal at any point of time. If you are having any particular doubt at any step, feel free to ask. Okay, this is the thing. At the beginning only. I am telling you. Okay, so if you are having any doubt in any particular step, then you please ask me. Okay. Elsewise, what is the thing is at the end also. If in the entire week's content you are finding difficulty in something, then you can ask. Okay, don't feel shy, don't feel ashamed. Okay, be very free. This is my personal opinion. Okay, I'll not be asking you again and again what doubt you are having. Okay, so at the very beginning I am telling you that whatever doubts you are having, feel free to ask them at any point of time. Okay, this is the thing. So the answer to this particular question will be C. Okay, no need to worry that how we got to this particular point. I'll just walk you through step by step. Okay, what is histogram localization? First you try to understand histogram equalization. Histogram equalization is a technique which is used in image processing to improve the contrast of an image. Okay, what do you mean by the particular term contrast? Okay, for example, if you are viewing this particular presentation, okay, as well as you are viewing me as well as the other participants on your particular device, maybe it is a tablet, maybe it is a laptop. Okay, so in that particular case, what is happening, that the image which is getting projected in front of you is at a certain frame rate. That is why you will feel that that particular content is moving. Means you are in an illusion that you are watching a video. Okay, video is nothing but a streamed set of images at a certain frame rate. Okay, this is the meaning of video. Maybe you are viewing me at 30 fps, maybe you are viewing me at 60 fps. Okay, this is fps. Fps is nothing but frames per second, means number of images which are getting displayed at a particular instant of time or in a 1 second. Okay, so regarding that, a particular term has been mentioned here, which is the contrast. Contrast means, in simple language, if you will try to understand, contrast is nothing uh, uh, but the term which is referred to as the distribution of the pixel intensity. Okay, how well distributed the pixel intensity is there in an entire image. Okay, and pixel is the very fundamental unit. Okay, in case of colored image, it is RG and B. In case of binary image, or in case of black and white image, it is just a value 0 or 1. Okay, that is the thing. Means how varied a particular pixel intensity is throughout the entire image, that is meant by the contrast. Okay, it achieves this by redistributing the image's pixel intensities to span over the wider range. Okay, in a sense, it creates tries to create a more uniform distribution of pixel intensity. Okay, leading to better use of the available dynamic range. Okay, this is meant by the histogram equalization. Okay, this particular concept is very very important in case of image processing, particularly when you are uh, going for some advanced research. Okay, so this particular concept is very very useful. Okay, where your task will be to find a particular attribute inside an entire image. Okay, and there won't be a single image, there would be thousands of images of that particular fruit, of that particular object. Okay, for example, in my field, okay, in agricultural field, if we have to localize a particular fruit in an entire video. Okay, video is nothing, as I already told you, it is collection of images at a certain frame rate. Okay, that is the meaning of a video. Okay, so what is happening here, a particular bounding box type of thing you will build in a certain image. Okay, and that particular bounding box values you will try to compare with every image which you will be receiving as the feed, and at the end you will be able to localize that particular feature or that particular object in the entire video. Okay, that is meant by histogram equalization. Particular technique is very important when it comes to image processing, object localization. Okay, this is the thing. See here, it is very well mentioned here in case of underexposure. Oh, okay, the image is too dark, most of the pixels are clustered in lower intensity, then you can use this particular concept to equalize, or you need to enhance all the pixel values to a certain level. How this particular thing is done, we'll just see. Okay, or it is a case of overexposure. Image is too bright, most of the pixels are clustered in high intensity values. Okay, in that particular case, or in case of limited dynamic range, the image was captured or processed in a way that restricts the range of intensity values. Okay, so core idea which you need to remember in the case of histogram equalization is to transform the particular image so that distribution becomes approximately uniform. Okay, if it is not uniform, then what will happen? Then the particular distribution which you are trying to look for in the entire image, you won't be able to fetch it. Okay, in this particular image of mine which you are able to see, what actually it is happening, this is a great example of computer vision. It is taking my particular image, how it is just able to detect what is the boundary of my particular image in this particular whole video frame rate, which is obtaining in real time in 1080 resolution, 1080 by something resolution. Okay, it is able to form the boundaries, and after that in real time it is able to put a real time background to it. Okay, so these particular operations you will be able to do only when you will be able to recognize a particular pixel intensity variation within a particular input image. Okay, I'm explaining you without any of the mathematical equations in a very simple way, because what I have realized that people enter in the classroom. Okay, they learn the things, they pass the course also, they obtain certificates, grades, everything also, but at the end, after the course is over, they are not able to appreciate very basic things, which at the end of the 4 years that is asked in the interview, or in the various interviews it is asked, as well as in the job interviews, everywhere it is asked. Okay, so particular basic level you should be able to attain. Okay, because at the end nobody will ask you that, sir, what, how in particular image you have to calculate this particular thing. At that point of time, formula are not that much important, but the basic idea you should be able to provide, since you have graduated or post graduated or you have done PhD in this particular field. Okay, that is what is my idea here in this particular case also, as well as teaching in IIT Kharagpur also. My basic idea is this only, that I explain everything in so simple language that at the end, after the course is over, still the student remembers it. If you are asked about it, okay, in any interview, you should be able to explain. That is my intent. Okay. Now we will see how this particular thing is calculated. Okay, histogram equalization, contrast enhancement technique, it is there. Okay, image processing and computer vision. It is used to improve the visual appearance of an image by making its intensity distribution more uniform. We have just covered. Okay, where you can use in many images. Okay, pixel intensity values may cluster within a narrow range. Okay, too dark it is there, too bright it is there, or low contrast is there. Okay, So in that particular cases, you would be you are required to use this particular concept. Okay. What is a particular histogram? Histogram is a graphical representation of the frequency of the intensity values. Okay, in an image. Okay, you are given a particular range of the pixel intensities. For example, in a grayscale image, if you are given pixel intensities from 0 to 255, that is black to white. Okay, so which particular number is appearing, how many number of times, that is dealt in histogram. Okay, that is the thing. So what is histogram equalization? Histogram equalization transforms the image so that the output image has a more uniform histogram. Okay, ideally it should be flat. Why ideally it should be flat? Because if it is not flat, okay, and variations are there, then appropriating or finding a particular intensity variation within a big frame rate would be very much difficult. That is why I am saying it that it should be uniform. Okay, that is the reason. Okay, it works by calculating the image histogram. It works by computing the cumulative distribution function. It works by mapping each pixel intensity to a new one. That you will just see in few minutes. You will see these steps. Okay, then you will be able to appreciate. Okay. So step by step is procedure has been given here. Okay, computing the histogram, calculating first how many number of pixels for each intensity value is there. Okay, then computing the cumulative. We'll just compute. Okay, then we will see normalizing the CDF or the cumulative distribution function. Okay, we will normalize using this particular formula, that is CDFI at that particular intensity value. What is the value? Minus CDF minimum over n, where n is the total number of pixels and CDF minimum is already there. Okay, then we'll map the values, old values to the new. Then you will multiply the normalized CDF by L minus 1, where L is the number of possible intensity levels. Okay. These steps are a bit hard to remember, but when we will solve a practical example, then they are very much easy to remember, as well as you will be able to appreciate it also. Okay. What is the outcome? That is the question of most of the students, that what is the outcome of our degree? What is the outcome of our course? What is the outcome of our life? So here, what is the outcome of this particular process which we have done? The pixel values are redistributed over a wider range. It improves the overall contrast, making hidden features more visible. That is the thing. Okay. Regarding this particular thing, overall contrast improving as well as making hidden features visible. Particularly in this particular field, I have worked a lot during my PhD research. If you are interested, then you can ask. I'll elaborate more on that. Okay. Then intuition behind CDF mapping. The CDF at a given intensity tells you what proportion of pixels are below or equal to that level. Okay. Okay. Then mapping using the CDF allows the each new level reflects the accumulated brightness of the image. In simple terms, this entire thing means that how much variation is there between the mean pixels as well as the final amount of the pixels which we are targeting or which we are looking. Okay. Applications, very very important. Okay, for the entire computer vision. Okay, for the entire computer vision, this particular thing, medical imaging, will always hold. Okay, whatever are the innovations which we are doing in computer vision, they are mostly applied in medical imaging. Okay, why they are applied in medical imaging, you can ask me. The reason is so because with the growing advent, the medical industry means not the hospitals and all these things, but the machines which are used to treat different patients, they are increasing. Okay, technology has to be increased because the number of diseases, the outcome of the diseases are increasing day by day. Okay, so that is why we are trying to uh, fetch the most advanced machines with the applications in medical fields. That is why this particular thing will always hold. Okay. So be keeping this in mind that after this course is over, if you are asked that, sir, you have invented this particular algorithm, you have applied this particular thing, and where you will use, okay, they will generally ask like this, okay. If particularly you are sitting for corporate interviews, they will ask like this, okay. They will be mostly governing about the basics, okay, basic mathematical aspects, as well as what is the use case, okay. So you can always explain to them that, sir, for medical imaging I'll use this particular concept, okay. Then it comes the satellite imaging. Okay, satellite imaging means imaging to relevant terrain. There you can use this particular concept. Okay, identification of different spatial features. There you can use this particular concept. For document scanning, for photography, enhancing the low contrast photos, you can use this particular concept. Okay. While there is a limitation also for everything, there is a pros, there is a cons also. Okay. Cons is this much only, that it might over enhance noise in uniform areas. Okay. What is noise? Noise means the unwanted data which is there inside an image, inside a signal. Okay, inside a signal, the unwanted data which is there, that is also noise. Inside an image, the thing which we don't want, that is noise only. Okay. So it may over enhance that also, because when you will be applying the algorithm, okay, you will be enhancing everything which is there inside the image. Okay, so noise will also get enhanced. That is what I want to say. Okay, not always suitable for color images unless applied carefully on luminescence like HSV or YUV. Okay, may produce unnatural looking images in some cases. Yeah, this is there. Very frequently you will be able to appreciate this particular thing in mid journey. Okay, it is there. Unnatural looking images it is producing. Okay, we will discuss someday what is this particular concept, generative AI and all of this thing. Okay, based on your interest. This is the code snippet Python using the OpenCV. Okay, import CV2, then import matplotlib.pyplot as PLT. Okay, then you are reading the grayscale image. Okay, img equal to cv2 dot imread. Okay, cv2 dot imread grayscale. Okay, then applying the histogram equalization. This is particularly done in Python. Always you just have to look for the functions because already they are built in. Okay, so if you are using built-in functions, then that will be very easy. Just you have to change the parameters and the attributes. Okay, that would be associated. Now you try to see that displaying the original as well as the equalized images and well as the plotting the subplots. As well as you are displaying the title, then plot.show, then you can plot.export also. If you are writing a research paper, then you have to use those particular options. So in summary, histogram is the count of pixels for of each intensity value. Okay. Then cumulative distribution function is there. Then running sum of histogram values. Then histogram equalization is there. And goal is to make intensity levels more uniformly spread to reveal then features. Okay, this is the thing. Yeah. Now you try to see the step-by-step procedure which is involved. Okay. To solve this particular question here, three star has here at this particular pixel intensity value, a star has been placed. Okay. So first thing which you will use when you are doing it with code is flattening the images. What do you mean by flattening the image? You are converting the entire array which has been given to you into a list. That is meant by flattening the image. Okay. This particular step you will omit when you are opting for this particular question in the examination. There you can omit this particular step. There is no hard and fast rule that you have to write it step by step, because there fetching the answer is most important. Okay, that is the thing. Then total number of pixels you will be able to count: 5 rows, 5 columns, 5 into 5 is 25. Then you get the frequency or the histogram of each intensity value. What is the value? What is the frequency? Very easily you will be able to get. Okay. 0 here is repeated 3 number of times, 1 here is repeated 3 number of times. Then similarly you can see. Okay. Then you are able to calculate the CDF, cumulative distribution function. CDF is the cumulative sum of histogram frequencies. Okay. entire thing in the same manner in which the histogram is prepared, that has been done here. Intensity, frequency is there. CDF is just the sum of the values which are there below that particular line. Okay. 3 for the frequency, this particular row, 0, 3 is there. So CDF will be 3. Here the frequency 3, this particular frequency has been added. So 3 plus 3 will be 6. Then 6 plus 5 will be 11. Then 11 plus 4 will be 15. Then 15 plus 3 is 18. Then 18 plus 3 is 21. And 21 plus 4 is 25. Okay. So now you will be able to obtain the CDF. Okay. This particular step has been completed. Now you see, then you apply the equalization formula. Okay. Histogram equalization formula you have to just apply. Okay. New value is CDF minus CDF minimum over n minus CDF minimum multiplied by L1 minus 1. That is the thing. Okay. In this particular course, I have prepared the PPTs for all 12 weeks as well as for the extra session which I will be conducting. And I am telling you well in advance, this is very mathematical. Okay. So whenever you are attending any of the sessions or my session particularly, please keep a notebook, pen, paper, everything with you, okay, as well as a calculator. That would be very helpful for you because as I am solving with you, you need to practice. Okay, that is the thing. That is why the name of the session is practice session. Okay. Yes, Mokbul Hussain, you want to say anything? Then please say.
We get the PPT or something.
Yes, you will get the PPT. No problem. But
Okay, sir. Thank you.
still it would be very very pleasant if you will have a pen and paper with you. Okay, in that particular case you can solve with me. That is what I am telling. Yeah, and you have written also one thing, but also manufacturing, retail, smart parking industry also implements. Yeah, yeah, in this particular case also implementation is there. In
Okay.
manufacturing, yes, computer vision is involved. Yeah, and retail also, yeah. Now it is getting involved. Nice. Smart parking industry, yes, as well as you can think many of the things. Okay, just basic 2 3 examples I was telling you. Okay, fine. Yes. Okay,
Okay, sir.
now you see the new value has been defined here: CDF minus CDF minimum and minus CDF minimum multiplied by L minus 1. So CDF minimum has been given here as the 3. That is the smallest non-zero CDF. 25, and you already know, and number of intensity values is from 0 to 6, that is in total 7. Okay, now directly putting everything in the formula, it will be 15 minus 3 over 25 minus 3 multiplied by 6, that is 3.27. And since the intensity values are integer, okay, so whatever the numbers which are there above 0.50, that you will round it to the value which is just less than that. Otherwise, greater the values 0.51 to 0.99, you will round it to the next integer value. Okay, you understood the point, right? If it is 3.89 or 3.51, it would be rounded off to 4. If it is 3.49 to 3.5, okay, similarly 3.27 or 3.1, that all will be values will be rounded up to 3. Okay, so the correct answer is 3. Okay, that is the thing. Yes. Now we proceed towards the next question. Note that the probability of a normal variable p z greater than 2.5 equal to 0.062 x is normally distributed variable with mean mu equal to 30 and standard deviation sigma equal to 4. Then you have to compute the value or the particular probability x less than 40. Okay, this particular thing you have to calculate, and your options have been mentioned. Okay, take 2 minutes time, read the question. Okay, and try to solve. Yes. I have provided you a particular link in the chat box and I have pinned it also. Okay. So in this particular link, you will be able to get all the PDFs as well as the YouTube recording links. Okay. For all the three sessions that would be mentioned. Okay. 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 Fine. Try to see. Okay. How you will approach, whether you are able to read the question, you are able to appreciate what are the particular variables. Try to see. Yes. Yes. Now we will see. Okay. Not much of your role is involved in solving. I can understand it because it's a long mathematical question. Okay. But do try to be actively present. If at any step you are finding any difficulty, then feel free to ask. Okay. In all of the sessions, okay, there is no hard and fast rule. Okay, that in my session you are active or in other sessions you are active. Whichever you are attending, feel free to ask. Okay. Yeah. The correct option would be B only. Okay. How you'll achieve it? Just see. Okay. Try to bear with me. First of all, you have to understand this particular concept that the probability using the normal distribution. One of the most important distributions in the statistics is the normal distribution. Okay. Detailed breakdown of the underlying ideas. Normal distribution, it is CPD. Okay. Continuous probability distribution. It is symmetrical about the mean. Okay. Described by mean mu as well as the standard deviation, which is sigma, and it is shaped like a bell curve. We'll just see. Okay. The key properties are mean, median, mode, all are same. Okay, it describes the many real world phenomena. Okay, height, test scores, etc. Okay, particularly this concept is very well used in case of modeling. Okay, in case of modeling, it is very well used. Okay, so the total area under the curve is 1. Okay, which represents the 100% probability. I'll just explain you with the help of a graph. Okay, this particular problem x follows a normal distribution. Here, this is the denomination. Okay. X follows means the tilde symbol is there. Normal distribution with mu equal to 30, mean equal to 30, and sigma, that is the standard deviation, equal to 0. Okay. This means values of x are centered around 30. Okay. Most values lie within a few standard deviations of the mean. Mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, okay, as well as mu minus sigma, mu minus 2 sigma, as well as mu minus 3 sigma. Okay, these are the values. Few standard deviations. That is the meaning here. Okay. Px less than 40. What does it mean? You are asked to find Px less than 40. Particularly, this thing means that what is the probability that the variable x takes on a value less than 40. That is the meaning here. Okay. In a normal distribution, this is represented by area to the left of the curve. Okay. Area under the curve to the left of 40. Okay. The x greater than 40 is on the right hand side. X less than 40 is left hand side. Okay. Why you are using a Z score? Because normal distribution tables only work with standard normal distributions. Okay, this you have to keep in mind. Where mean is 0, standard deviation is 1. Okay, so to use those particular tables for which the Z values have been already calculated, you have to convert using the Z score formula, that is x minus mu divided by sigma. This particular Z score tells you how many standard deviations a value is far from the mean. Okay. So here if you will try to calculate the Z value, it is Z equal to x minus mu divided by sigma. Okay. X is 40 here, mu has been provided to you as 30 and sigma is 4. It will come around 2.5. It will come exactly 2.5, not around. It will come exactly 2.5. Okay. So x equal to 40 is 2.5 standard deviations above the mean. Okay. Visualizing this particular area under the curve, total area under the normal distribution is 1. Okay. Area to the left of z equal to 2.5 represents this particular probability, that is z less than 2.5. Okay. That is x less than 40. Okay. So probability z greater than 2.5 equal to 0.02. Hence the probability z less than 2.5 is 1 minus 0.062, that is 0.938. And I think which particular option will be correct, that we have just to see, that is B is the correct option. Okay. So concept summary is this, that normal distribution follows a bell-shaped curve and it is used to model many real life principle. Okay, many real life phenomena. Now you just have to think about that whenever a particular distribution or particular data which you are having, it will not follow the normal distribution, that which type of approach you will follow to model that particular data. Okay. For example, in today's world, if autonomous parking has to be designed for a particular mall, then you have to model that particular thing first. Okay. Then you have to prepare an algorithm, then you have to execute the algorithm, then you have to work on the optimization, then you have to increase the efficiency. But first you have to understand that what is the variation. Okay. What exactly most of the data can be modeled in which form or which equation. Okay. That is the first step. Okay. So in most of the cases in real life phenomena, you would be able to see, okay, that this particular distribution is there. Okay. Z scored is a standardized value that tells how far a value is from the mean. Okay. Px greater than x less than 40. Probability that a value is less than 40 represented as area under the curve to the left of 40. Okay. Standardization converts any normal distribution to the standard normal distribution using the Z score. And once standardized, we find the area under the standard normal curve using the Z curve, Z table, or the known values. Okay, this is the thing. What is this distribution? A special case of the normal distribution, also known as standard normal distribution. Okay. Then shape already told you, mu, sigma, everything told you. Total area is 1. Okay. This is the shape of the normal distribution, which I was telling you. Mu is in the center. Okay, mu plus 1 sigma and mu minus 1 sigma or mu minus sigma will give you 68.3% of the total net data variation. Okay, as well as mu plus 2 sigma and mu minus 2 sigma will give you 95.5% of the entire data variation, as well as mu plus 3 sigma will directly give you 99.7% of the total variation. And you must remember that whatever the values which will be there after this particular mu plus 3 sigma and mu minus 3 sigma will be not of much use. That is what I want to say here. Okay. Now, in this particular case, why we have done this particular thing, okay, why we have used this particular formula z equal to x minus mu upon sigma, already told you, as well as why it is used and what are the chances, everything has been explained to you. But try to remember the real life examples, okay, standardizing the tests like SAT or GRE, okay. It is very controversial nowadays, okay, how the marks are standardized and that they are given to the students, particularly in NEET or in the JEE. Okay, it is very controversial, but still you must be in a position to appreciate that these particular distributions are used. Okay, they sometimes give you the formula also how they are normalizing. Okay, but that particularly is very much controversial. Okay, still you should be in a position to understand that what is the particular formula that the people are using. Okay, so in most of the cases it is normal distribution only. Okay, Quality control in manufacturing. Yes, from this particular example, you should be able to appreciate that this particular concept is very, very important in case of quality control in manufacturing. Okay. How? For example, a milk factory is there. Okay. It is packaging uh, packets of processed milk. Okay. And it has to maintain the contamination of the particular species of bacteria within a certain proportion. Okay, it is x less than 0.00025. So how it will ensure that this particular contamination level is getting maintained. This is a very important thing. Okay, in batch processing, maybe they are producing 10,000, 20,000, 30,000 packets at one particular time. Okay, so how they are particularly ensuring? How? What is the procedure? They'll just take sample. Okay, random sample they'll take, or they'll prepare a particular strategy to take a sample, and after taking the sample they will check for the microbial contamination. What is the exact level of the microbial contamination? Okay, and then out of 100 samples, 200 samples, if they are able to achieve the desired value of the contamination, then their product would be acceptable within the market or non acceptable in the market. But how they are deciding that whether they have achieved the level of the contamination or not achieve the level of the contamination, that is particularly designed while knowing that what is the particular distribution. Okay, how the particular contamination is distributed among my packets. Okay, suppose a batch of 100 milk packets is there and I am taking only two samples, then I should be able to appreciate and say confidently that within this particular error margin, I am very much confident that the all the 100 packets will be having at much this particular value at maximum contamination level. Okay. Similar thing you can imagine for your uh, alignment of the different automotive parts. Okay, this is the thing. So you should be able to appreciate the concepts which you are learning. Okay, this is my intent. Okay. Then in case of medical statistics, comparing the blood pressure to the normal range, this is very, very useful. Okay. As well as every other algorithm is there in business. So in finance, analyzing the stock returns, you can use that. Okay. This is a default use case. Okay. Generating money. Okay. Fine. Yeah. Then how we done it? Okay. This particular thing already explained you. Step one, what is being told, then z equal to x minus mu upon sigma, then probability. This is just a repeat, okay? And final answer we are getting 0.9380. Okay, this is the thing. Yes. Then moving on to the next question. Okay, feel free to ask anything anytime. Okay, in between. If you are having any problem, then feel free to ask. I am having a very limited time of 2 hours. Okay, I can extend it to 2.5 hours or at max 2 hours 45 minutes, and I have to tell a lot of concepts. Okay, that is why I am not stopping. Okay, feel free to ask anything. Okay, yes, yes, Makbul Hussain, you want to say anything?
Sir, is this question from the assignment or other than assignment?
Yes, this is very important that whether you are solving the current assignment, you are solving previous assignment, you are making your own questions. Okay, so I want to say it is mixture of all three. But current assignment I'm not solving. Okay, that is for you to solve. Okay,
Yes. Okay, sir. Okay,
okay,
understood.
yes. So I have made
And
some of the questions. I have also solved previous assignments. Then I have seen a lot of books, and this is mixture of all those. Okay, for your own
and
practice. Okay.
okay. And one
Yes.
thing I just appreciate that you also told that the application of use case, all
Yes.
the
Yes.
things
Yes. Yes.
that's
Yes.
great for us.
Yes. 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 Thank you so much. Okay. Yes. The rest of the students, please try to solve. Okay. Be interactive in between. I appreciate it very much. Okay. Because monologues are not that much useful. Dialogues are very useful. Okay. For you to remember the concepts in later stages of your life. Okay. Yeah. In my previous lectures, I used to feel good in introducing the students and all of the things, but now the content is too much. Okay. So in the last time, if I'll find time, then I'll just ask you from where you are, okay, and what you are doing currently. Yes. Okay. Feel free to solve. Try to put on your precious efforts in solving the questions. Okay. So in the examination, you will be able to pass with flying colors. Okay. Yes. Yes. Now, if you see this particular question, consider two images, each of size 16 by 16. I1 and I2 are the names. Then image I1 has 192 and 64 pixels for foreground and background, respectively. And I2 is having 64 and 192 pixels for foreground and background. Okay, nothing much to worry. Then one pixel is selected at random from one of the two images and it is found to be background pixel. What is the probability or find the probability it was drawn from image I1? If this is the thing, okay, it is a much detailed question is there. At if one point of time, if you will follow each and every information, then maybe you are frightened or you might leave this particular question in the examination. But it is a very easy thing. Okay, it is a very simple question based on Bayes theorem. Okay, we'll look at the Bayes theorem. What is the concept? Okay, how this particular concept is dealt. Okay, and after knowing the concept, you would be very easily able to solve this particular question. Okay, that is what my idea is. Okay, correct answer for whomsoever have solved is A. Okay, it is 1 by 4. Okay, we'll just see it in detail. First of all, what is Bayes theorem? Bayes theorem, it is a fundamental concept in the probability that describes how update probabilities when we get new evidence. Okay, it answers given that some particular event has occurred, then what is the probability of another related event being true? Okay, that is the thing. Okay, conditional probability. For conditional probability, this particular theorem, Bayes theorem, is used. Okay, try to remember. Particular event has happened. Okay, and then we are asking that some event has occurred. What is the probability of another related event being true? That is the thing. Okay. So now you try to see what is the formula and all those particular things. Conditional probability of A slash B or P A slash B means B is the event that already has taken place. Okay. That is given by probability B slash A multiplied by PA over PB. Standard definition, standard formula given as Bayes theorem. Okay. What do these particular terms mean? Very, very important for you to understand. Okay. PA is the prior probability, how likely A is before observing B. Okay. Then probability B oblique A is the likelihood. How likely B is given that A is true. Okay. Then probability of event B is the evidence, total probability of observing event B. Then probability A oblique B is posterior. That is updated probability of A after seeing B. Okay, this you must understand. When you will be using this particular Bayes theorem for diagnosing a disease from test results, for determining source of the signal. Okay, source of the signal, very very important use case is there. Okay, this you must remember. Bayes theorem you already is covered in the lectures. Okay, in the video lectures which we provide at the end of in one in at the interval of weekly. Okay, weekly interval we always try to provide the recorded video lectures. But the use case I am explaining you here, that determining the source of the signal. For example, there are two particular radio signals which you are receiving. Okay, one particular radio signal you are receiving from 5 kilometers away, and other one radio signal you are receiving from 100 kilometers away, and in between there is attenuation as well as amplification, and after that you are receiving, then you should be in a position to say that, sir, from where the particular signal is coming. Okay, what is the source of that particular signal? Okay, so you cannot directly say ki, sir, this is the source of the signal. GPS will never give you directly what is the location, but it will give you a probabilistic idea that, sir, this is the broad domain or the broad term between which my location is very well defined. Okay, between this particular range, sir, this is the probability that signal is coming from 5 kilometers away or 500 kilometers away or 100 kilometers away. So in those particular cases you can use this Bayes theorem directly. How, you will just see. Okay, then spam filtering, yes, you have to take the decision in real time that whether this particular email is spam or not. Okay, since I am assuming most of us are computer science students, so accordingly I have set the examples. If I find that the students are from other domains, then I'll set the examples in that particular format manner. Okay, then updating beliefs based on the new data. Okay, means belief system or the generative system or generative AI system that is truly based on this particular thing. Okay, you have to understand the emotion of the market, that is meant by this particular thing, updating beliefs based on new data. Okay, anytime you want to reverse conditional probability, Bayes theorem is the particular tool which you will use. Okay, for example, 1% of a population has a rare disease. A test for the disease is 99% accurate, and you have been tested positive. What is the probability that you actually have the disease? Okay, so a lot of independent events are happening at the same time. Okay, 1% of the population is having a rare disease, and that particular test which we are just taking, it is 99% accurate. Okay, and the test has come positive, then what is the probability? So all these events are independent. Okay, so that is the thing. This rare disease can be anything. Okay, this is the thing. So then how you will define D is the has disease, or plus is the it is tested positive, and minus is sorry, probability of D is 0.01. All these things will be given to you. I have framed a particular example for you to just see. Okay, then probability of testing positive and having disease. Okay, then probability of testing positive and not having disease, then probability of not having disease, and then we want to calculate the conditional probability that you have been tested positive and you actually have disease. Okay, and then you will use the Bayes theorem, and first to calculate this particular p positive, okay, you will apply this particular formula. Okay, that p conditional probability of testing anyone means the total sum of probability p plus. Okay, that will be sum of the all probabilities. Okay, in probability, plus means or, and dot means or multiplication means and. Okay, this is the thing. I'll just write it down here. Okay, in terms of probability. There are other ways to solve also. Okay, if you are not using Bayes theorem, that is not very compulsory, but Bayes theorem, it gives us the very clear cut idea. That is why I use the Bayes theorem. Otherwise, in using other methods also you can solve. Okay, so multiplication always means and. Okay, and plus always means or. This is the thing. Try to remember this. Okay, so when I am calculating that in which, what is the probability or what are the scenarios in which a particular person is tested positive, then I have to take all the scenarios that it is tested positive. Okay, while he actually has disease, at the same time he should have disease, or means second case, he's tested positive, he's not having disease, and he's at the same time he should not have disease. Conditional probability multiplied by actual probability of happening the event at the same time. And when you are summing, you are getting the entire thing, and after that you are using the entire formula, okay, to get the answer. This is the thing. General interpretation, prior knowledge matters, or prior knowledge exists. That is what I want to say. That prior knowledge is existing. Then only I am saying you that that this particular probability I am calculating. You don't just have to look how strong the evidence is. You also have to consider how likely this particular event will be happening. Okay, he's. It is not very true to say that he's tested positive or negative. Okay, it should be falling in that particular domain also. That is the thing. Okay, now back to this particular question. You saw a background pixel. Okay, you wanted to know which image did it most likely come from. Okay, so Bayes theorem has helped to calculate the probability of that particular image I1, okay, coming from background. Okay, then you will try to formulate this particular expression. Okay, yes, Makbul, you want to say anything? Hello, anything you want to say? You are not audible right now. You can always use the chat box. Okay, if some thing is there, okay, a lot of students are there, that is why I am telling you, you can use the chat box also. Okay, yes, yeah, we are given in Bayes theorem, okay, that each image is of size 16 by 16. Total how many number of pixels are there? 256. Image I1 foreground is 192, background is 64. Image I2 foreground is 64, background is 192. Okay, pixel is randomly selected from one of the two images, assuming equal probability either of choosing I1 or I2. That by default I am taking the liberty, but it is not in the actual case. Okay, okay, 1 by 2 won't be there, but here I am assuming. Okay, and it turns out to be a background pixel. We have to find what is the probability that this particular background pixel came from image I1. So using the Bayes theorem, already we have formulated probability of uh, background pixel coming from image I1. Okay, that is probability of first selecting the background image from image I1 multiplied by probability of selecting image I1 upon probability of background. Okay, probability of selecting background. Okay, uh PD slash plus, here this particular slash symbol is divided only. Yes, it is divided only. Very correct. Okay, here I have written it with the help of shift plus key adjacent to the uh, square bracket. Okay, so you can use it this particular notation also, as well as you can use slash also, this particular symbol also. Everyone will be able to understand either this or this. Both are good. Okay, this is also correct, this is also correct. This is the thing. Okay, yes, finding the individual probabilities I1 I2, assuming it is equal, it is 1 by 2 only, then probability of selecting the background from image I1 is 64 by 256. Total number of pixels, if you will see, 192 plus 64, that is how much? 256. Okay, so 64 upon 256. Then probability of background selecting an image, selecting the background from image I2, that is 192 over 256. Okay, 3 by 4. Then you calculate the total probability using of choosing a background pixel in the similar way in which we have calculated for the previous example. Okay, so likewise, if you will try to calculate, it will come around 1 by 2. Okay. First of all, probability of selecting the background from image I1 multiplied by this particular image I1 is selected. Okay. Both the events have to happen simultaneously. That is why I have put a dot. Okay. Multiplication. Or if you select the background from the image I2, as well as you simultaneously select the image I2, Now you try to see that 1 by 4 into 1 by 2 plus 3 by 4 into 1 by 2. That is final answer coming as 1 by 2. Then you try to apply the base theorem already formulated and you will get the final expression as 1 by 4. Okay. This is thing and very very important, and within the entire course duration, okay, you will be using this particular concept a lot. Okay, so if anybody is having any doubt, feel free to ask. Okay, this is my thought. Okay, I hope it is clear. Anybody having any doubt, any point of time, feel free to ask. Okay, I am having a very shortage of time, that is why I am not asking individually. Otherwise in previous sessions I asked students individually also. Okay, very sorry for that, but time is decided by the administration, not by me. Okay, yeah. Next question, try to read it. Okay, try to solve. I'm just coming in 2 minutes. Okay, yeah. Yes. Moving on to the next question. Okay. An image taken using a camera can be enhanced by different techniques. Suppose a software is developed which can detect if an image has been enhanced or not with 96% accuracy. Yes, I appreciate that. Okay, very good. It is, I think, C only. C 0.9863. Okay, okay. We'll just see. Okay, I'll read the question, then we'll see. Okay, I thought you were answering previous question, but if you are answering this one, I really appreciate it. Image has been taken using a camera that can be enhanced by different techniques. Suppose a software is developed which can detect if an image has been enhanced or not with 96% accuracy. Survey is done. It is found 75% of all images are enhanced. Okay. If a particular software is predicting that an image is enhanced, what is the probability that the image is actually enhanced? Okay. In these type of questions, in particularly these type of questions, this particular concept of Bayes theorem will apply. Okay. Yes. Yes, it is 100% correct. Makbul has solved it very correctly. It is C only. Okay. I really congratulate him for that. Okay. We'll just see classic Bayes theorem problem. Okay. Let it be that image is enhanced, not E. Okay. This particular not, you can write it down in the examination like this also. Either this or this or like this. Everything is fine. Okay. So don't worry much about the symbols, sir, that I am making like this. Will my marks be detected? No, your marks won't be detected. Okay. This is the thing. Just a second. Yeah. All these three are very well. Okay. This is the thing. So probability of happening of event E has been given as 0.75. Okay. Not E, that is 1 minus 0.75, that is 0.25. Accuracy is 96%. Okay. Meaning probability of happening of event E, okay, after event E has happened, that is 0.96. Probability that software correctly predicts the enhanced image. Then what is the probability of happening of event P predicted image which is not the image E, that is 0.04. False positive rate. Software wrongly predicts non-enhanced as enhanced. Okay. Then you have been asked if the software predicts that an image is enhanced, what is the probability it is actually enhanced? Okay. Probability of happening of event E given that probability the event P has already happened. Okay. Using Bayes theorem, try to formulate. Then first of all, try to calculate the probability of happening of event P. Okay. Then you apply Bayes theorem similar to the case which I already explained you, and finally you will get the answer as 0.9863. Okay. Both the questions, this question number 3, this question number 4, based on the same pattern. That is why I am not explaining much. Okay. Try to see these particular two questions. Okay. Then you will be able to realize. Okay. That the same concept has been used here. Okay. This is the thing. Yes, one student has solved. Very good. Do try to solve, okay, in the class here itself. Okay, take pen, paper, notebook, calculator, everything, whichever you need, as well as a water bottle if you require it. Okay, try to solve each and everything here itself. Then this particular question, these particular questions, please try to remember. I am just explaining you 10 questions or maybe 15 questions in a particular session. But whenever a simple question is there with folded hands, I want you all to solve these type of questions in the examination because these are bonus questions. In the rest of all the questions, you have to do multiple calculations in order to achieve the answer correctly. But these are the bonus questions. Okay, these particular type of questions you would be able to very easily solve if you know the concept. Okay, so we don't have to leave these type of questions in the examination. This is the basic idea which I want to say to you. Okay, this is the thing. Yeah. Try to give your opinions if you have any. Rest we'll see. Yes. Don't understood the question? Okay, I'll explain you. No problem. No problem. Very simple. Continuous time signal is given by xt is exponential minus 2t then ut. Its Fourier transform x j omega is given by, and it is a MCQ. MCQ means single choice would be correct. MSQ means multiple select question, means two more than one choice can be correct. Okay, is the thing. Since it's units impulse signal UT, the answer is straightforward. Okay, Dinesh, then what is the answer? Correct answer, yes. Very sorry for this. I already have written. Okay, by mistake I have written. Yeah, it is A only. Okay. Now we'll just see the concept. I think some mistake is there in formulation of the slide. Okay, it is A only. Okay. What is Fourier transform? It converts time domain signal xt into a frequency domain representation x j omega. Okay. It helps us to understand what frequencies are present in a signal and how strong they are. Okay. So what signal are we transforming? You are given xt as exponential minus 2t ut. Exponential minus 2t is the exponential decaying function. Ut is the unit step function. It makes the signal 0 for t less than 0 and active for t greater than equal to 0. Means xt is defined only for t greater than 0 and it decays exponentially with the time. Okay. So it's causal and stable signal. Okay. If it is unstable, then it won't be decaying exponentially with the time. Okay. With the time, it would be attenuating. Okay, the equation of the function would also have some terms which would be directly dependent on the algebraic powers of time. Okay, this is the thing here. Okay, so standard Fourier transform pair which is used here, very common transform pair, that is e raised to power minus 80 ut is equal to 1 upon a plus j omega. Left hand side is in time domain while right hand side is in the frequency domain. Okay, for a greater than 0. So now you have been given in a particular standard denomination, that is xt e raised to power minus 2t ut, and a has been directly, you would be able to fetch a as 2. So standard transformation, it would be 1 upon 2 plus 0. Okay. So then it is 100% correct. Okay. The answer is indeed 1 upon 2 plus 0 omega. Interpretation of the result, the function x j omega is complex valued, describes how frequency is omega. Okay, how this particular frequency is contributing to the signal. Okay, directly you would be able to plot either in MATLAB, okay, or in Python, and you will be able to see that what is the variation and how the signal is varying with frequency. Okay, shows that higher frequencies have lower magnitude, that is the signal is smooth and not oscillating. Okay, this is the thing here. Yeah. So step by step here I have solved, and the standard transformation I have used, and I have been able to obtain the answer as 1 upon 2 plus j omega. Yes. Yes, you must have learned this in various courses. I appreciate it. Okay, no problem. Why we are using Fourier transforms for communications, control systems, image processing? We are often using the Fourier transform as well as other applications. I am able to tell you like in near FTR. Okay, then IR image sensing, then spectroscopy, Raman spectroscopy, then tunneling microscopy. This particular concept Fourier transform is very well used. Okay, for analyzing the signals which are coming in a particular frequency. Okay, for designing the filters, for understanding how systems respond to different frequencies. Okay, this is very well used. Okay, signal was given to you, you use the unit step, then you use the Fourier transform, then you applied a particular formula and you got 1 upon 2 plus j omega. Okay, very well it is taught in, I think, second year in electrical engineering courses. Okay, very well it is taught there. Okay, yes. Moving to the next question, very interesting question. I want most of the people to attempt it. Whomsoever are present, try to attempt it. Okay. Need not to be you are very correct in the very first attempt, but you can always look for these type of questions in the examination, like an eagle. Okay, because they only come for providing you marks. Okay. In rest of the questions might be you are committing some mistake, your options are not matching, and all of these things are happening. But these type of questions are bonus questions. Okay, so never leave them. It is my intent. Consider a binary image with a small fully filled white circle on a black background. How does this image look after applying image gradient operation? And our options have been given same as original image. Okay. A thin line surrounding the boundary of that fully filled white circle, a thin line surrounding the boundary of whole image, or an image with a white dot at the center. This you have to determine. Yeah, image gradients would be done in partial derivative form. It should be tangent, I believe. Okay, very good. Then what would be the correct option according to you? I got it the point. It is done in partial derivative. Yes, you are correct. Okay, a thin line surrounding the boundary of that fully filled white circle. Okay, good. Anybody else will like to communicate his opinion? His or her opinion. Very sorry. Yes, anybody else? Okay, we'll just see what is the correct option. Okay, it would be B only. Okay, why it would be B? I'll explain you. Dinesh is very much correct. Okay, it would be B only. What is image gradient? Okay, image gradient. The image gradient is an operation that measures the change in intensity. Okay, change in the brightness level between neighboring pixels. It highlights edges in an image. That is, places where the image brightness changes rapidly. Common gradient operators. Okay, common gradient operators are Sobel, Privet, Roberts, Laplacian. Okay, Laplacian operator is the particular partial derivative or the second derivative operator. Okay, given by del 2x over del x2 plus del 2 over del 2z or del 2f over del y2 plus del 2 f over del z. Like this is it is the Laplacian operator. Okay. You have been given a binary image. The pixels are either 0 or 1. Okay. And a fully filled white circle on a black background. So inside the circle, the pixel value is 1. Okay. Outside the circle, the pixel value is 0. Okay. Boundary between the black background and the white circle is where pixel intensity changes. After applying the gradient operation detects edges where there is change in the intensity. Inside the circle, there is no change in the intensity, hence the gradient will be 0. Outside the black area, there will be no change in the gradient. So, there will be no change, hence the gradient will be 0. But at the edge of the circle, okay, there will be sudden change. That means there would be a high gradient. Okay, gradient is nothing but the change. Okay, change in pixel intensity. That is what is measured using gradient. Okay, so visual result which I'll be able to see, it would be a thin white ring or line exactly where the circle's boundary was. Okay, so rest of the image will be black because there is no change in intensity there. Other options are definitely wrong. Same as the original image, no. If you are a blank gradient to any particular image, no, it won't be same as the original image. Okay. Then thin line surrounding the whole image, no. No intensity change at image border is unless there's a pattern there. White dot at the center, no. It is just opposite to what is the correct option. Okay. That is the thing. So final answer is a thin line surrounding the boundary of that fully filled white circle. Okay. Yeah. Now the next question, consider following 3-bit grayscale image and what is the vertical Sobel operator, horizontal Sobel operator applied to that orange colored pixel. Very much interested in that orange colored pixel. Okay. So if you know the procedure, then please try to proceed. If you don't know the procedure, please read the question, take a note of it, and at the end I'll explain within few minutes. Okay. Yes. Do try to answer. There is no issue. Try to at least solve, take a note of the things. Okay. Then I'll explain you. No issue is there. Okay. Yeah. Take your time. No problem. Okay. Take 5 minutes time. Try to recall what are the operators, what is the masking, what is the value, which concept it is asked. Okay. Then try to solve. Okay. No problem. Yes. Now you try to see the correct answer would be B. Okay. That is 7 and -3. They would be the correct uh, values when Sobel operator as well as the vertical Sobel operator and the Horizontal Sobel operator are applied on the orange colored pixel. How we will proceed, that we'll just see. Okay. First step, extract a 3 by 3 neighborhood. 3 by 3 neighborhood around the pixel 5. Okay. So your matrix was this one. So 3 by 3 neighborhood, what would be the elements? 0, 1, 3, 152 and 0, 3, 2. Okay. 0, 1, 3, 152 and 0, 3, 2. Then directly using the Sobel operator already taught in theory portion. Okay. Horizontal Sobel operator very very important. Okay. The mask you have to remember. That is nothing but -101, then -202, then -101. This is the horizontal Sobel operator mask. Okay. When I am saying a mask, what I want from you to understand that when you are using a mask, you have to multiply the elements as it is. Okay. One matrix you have to overlap with the other matrix in your head, and then you have to calculate what is the sum of the products. I don't want you to calculate using the standard matrix multiplication, that is multiplying the values row by column, that you don't have to do. Okay. So this particular mask has been given to you under 3 by 3 neighborhood. I have already fetched. So I'll multiply the elements each step by step. Okay. So this particular 0, first 0 I'll multiply with -1, then 1 I'll multiply with 0, then 3 I'll multiply with 1. Similarly, 1 I'll multiply with -2, then 5 with 0, then 2 with 2. Then you see here 0 with -1, okay? Then 3 with 0, then 2 with 1, okay? So finally, what value I'll be getting? I'll be getting the value as 7. Now you have to remember the vertical Sobel operator mask. Okay, that is 1 to 1, 0, 0, 0, and -1, -2, -1. And similar to that, when you will proceed, you will get the answer as 7 and -3. Okay, so correct option is option number B. Okay, yes,
Sir, how horizontal simulator operator are these metrics are come? Can you explain?
yes. This particular derivation, if you want to know, then please see our particular video lectures. Okay.
Okay, okay,
There it has been very well explained using the standard denominations. Okay. If you want
okay,
me to explain this particular concept, please bear with me, and in next class I'll prepare the slides accordingly. Okay. Because
okay, sir.
if I'll write, if I'll denote, then the entire session will be spent on this particular concept. Okay. This is the thing.
Okay, sir. Okay.
Either you can visit it, or in the next class I'll prepare. Okay. In brief, I'll tell you that how this particular matrix we are able to achieve. Okay.
Okay.
Yes. Yes. Next we'll move forward. DLT, a particular very very important concept. We'll just see. Consider the direct linear transformation algorithm for the point xi dash or xi mark with corresponding to xi, which involves the following equation using homogeneous coordinate representation of points xi dash and xi in the transformed and original 2D projective space, where H is the project transformation. X dash is analogous to Hx. Choose the correct option from the following. Vectors x dash and hx may have similar magnitude but different direction. Vectors x dash and hx may not be equal. They have similar direction but different magnitude. Vectors x dash and hx may be equal. They have similar direction and magnitude. Cross product of x dash and hx is a zero vector. This is the standard MSQ using DLT. Okay, direct linear transform. Okay. So if you will know this particular concept, B, C, and D would be correct. Rest all the options, rest option A is left. It is not correct. X dash and HX may have similar magnitude but different direction. No. If this is correct, then C and D are not correct. Okay. So hence A is only incorrect. Rest B, C, D incorrect. Okay. What is DLT? DLT is an algorithm used to estimate a projective transformation between two sets of points in 2D or 3D space based on point correspondence. It is called direct because it directly forms and solves a linear system, linear transform. Okay, because it models the transformation as a linear system in homogeneous coordinates. Okay, it is used for camera calibration, very very important utility. Okay, camera calibration, 3D reconstruction, then AR and VR techniques, then image rectification. Stitching and mosaicing, these two are very very advanced concepts. Okay, stitching and mosaicing, these in brief I'll explain you. These particular concepts are very well used for creating a 3D reconstructed map from 2D points. Okay, from 2D images you would be able to obtain a 3D image. Okay, reconstruction of 3D map from a 2D from a uh, set of 2D images using stitching. Stitching means nothing but overlaying of different images with one another. That is stitching. Mosaicing is nothing but creating a final contour or the curve along the stitched images. Augmented reality, most of you must have experienced that particular concept. Augmented reality is nothing but making the augmented world from stitching various 2D images only. Then you have been introduced with 3D reconstruction. 3D reconstruction is nothing but the same concept. From 2D images captured at different angles, you are projecting it onto a 3D plane. Okay. Then camera calibration is also there. Okay, camera calibration particular concept is there. Okay, there we are using it. What do you mean by camera calibration? Camera calibration is nothing but getting the depth or the distance from the particular 2D images. Okay. For example, here in this particular small box, you are able to see me, but at the same time, you are not able to determine what is the distance between me and the camera. Okay, that you will be able to do if our camera is calibrated. Very standard use of computer vision. Okay, standard and very basic use of computer vision in order to calculate the height, calculate the width, as well as calculate the distance. These three very very important things we calculate from an image using Python. Okay, this is the camera calibration. Okay, then DLT for homography, the core equation is this particular one, xi transform xi dash analogous to hxi. Okay, xi is xi yi1 transform, xi dash is transform of this particular matrix. Okay, transform operation you already know in the matrix, changing the row and columns. Okay, H is 3 by 3 matrix. Okay, then understanding the similarity or analogity. Okay, this means the vectors are in the same direction. Okay, and not necessarily equal. That is why we operate in homogeneous coordinates. Step 1, normalize the points, means improving the numerical stability. Usually involves translating and scaling the points so that they are centered and have a mean distance of root 2. Okay, not much well understood here. This all the concept along with the numerical example we will see in week 2, week 3. Okay, so here I have just introduced it as well as a particular concept I will just try to teach you. Okay, details we will just see in the following weeks. Okay, along with the numerical example. Step 2 is to create linear equations. Okay, this particular thing, xi analogous to xi dash. Okay, then analogity we will just try to maintain between these two sets of equations, and rewriting we will get the expression ah equal to 0, where a is the matrix of known coefficients from points and h is the vectorized form of homography h. Then solving using SVD, that is the singular value decomposition. I'll just teach you this. Okay, this concept I'll teach you. Solution is write singular vector corresponding to the smallest singular value, then reshaping this particular smallest into a 3 by 3 matrix. Okay. Minimum requirement is each point pair gives two equations and 3 by 3 homography has 8 degrees of freedom. Okay. So you at least need 4 into 2, that is the 8 number of equations. That is the thing. limitation of this particular method. Okay. Now you try to summarize everything. What is the input? Input is the pair of corresponding points. What is the output? Homography matrix H. How we are achieving it through SVD. What is this SVD? What is the core concept? I'll just tell you. Okay. Then core equation we already have formulated. Then linear system we have formulated. Then solving the equation. This is the basic idea. I know it is very hazy for most of us. No problem. But in the next particular sessions, we'll just delve deeply into it. We'll solve it, we'll formulate it, and we'll see it. Okay, bear with me. Then in here it is written, same equation it is written, okay, as well as homogeneous coordinates. What is the symbol? Okay, tilde symbol. This is known as. Okay, evaluating the options vector x dash and hx may have similar magnitude but different direction. No, it is incorrect. Homogeneous vectors are defined up to scale, so direction matters. Direction must be same even if magnitudes are different. Then x dash and hx may not be equal. Yeah, they may not be equal. They are analogous. Okay, they have similar direction but different magnitude. Yes, definitely can happen. But in vector theory, they should have similar direction. Okay, this is the thing. They can have different magnitude because that is what tilde symbol means. Same direction, different magnitude. Okay. Then vectors x dash and hx may be equal. Okay, they have similar direction and magnitude. Yes, it is correct. If it is so, then what can be more analogous to the original vector? Okay. Then cross product of x dash and hx is a zero vector. Yes, two different scalar multiples of each other, that is same direction. Okay, same direction. We have seen in this in option number B, then option number C also. So if two vectors are there in the same direction, then you already know sine 0 is 0, hence cross product will be 0. Okay, so B, C and D will be correct. Now I promised you to explain this particular SVD. I'll just explain. Okay. uh, I think I don't have the slides. I'll just explain you in coming class. Okay, very simple. It is there. U summation A transform. That is the standard denomination. Okay, we'll just see that. Next, focusing on this particular question, very simple thing. Okay, N- uh, d- leave question number 8 just for the time being. Okay, this in great detail I'll explain you with a numerical example. Okay, bear with me in this coming session. Knowingly I'm just leaving it for the coming session. Okay, and in the coming session I'll explain you how that particular Sobel operator equations came into well-being. Very interesting derivation, we'll just see. Okay, consider a 3-bit gray scale image with dimension 32 by 32. What will be the range of values in its x-axis? Whether it will be 0 to 7, whether it will be 1 to 7, whether it will be 0 to 15, or it would be 0 to 255. That you just try to see. Okay, easy question, easy explanation. Okay, no particular confusion is there. Okay, yes, correct option is answer. Correct answer is option number A only. For a 3-bit image there are 2 raised to power 3 intensities. I'll explain you what do you mean by this. You are given a 3-bit grayscale image, size is 32 by 32. Okay, this is about the special dimensions of the image, that is width and height. Question is asking what is the range of values in its x-axis. This should be a bit more ambiguous, somewhat more ambiguous, but it is very simple. What pixel intensities values are possible in 3-bit grayscale image? Focus is not on the special dimensions, that is 32 by 32, but rather grayscale values. Okay, which is the standard when dealing in the bit depth. Okay, so bit depth in images is how many gray levels can be represented. For n number of bits, the total number of possibilities are 2 raised to power n. How this came into picture? Because it is gray level. Gray level means either it will be white or black, 0 or 1. So how many number of values are there? 2. So for n number of bits, there would be 2 into 2 into 2 into 2. So 2 multiplied by 2 multiplied n number of times. So it will be 2 raised to power n possibilities, possible gray values. So here 3 has been already given to you. So 2 into 2 into 2, that is 2 raised to power 3. The 8 number of levels are possible. They are generally designated between the numbers 0 to 7. Okay. So 3-bit grayscale values have been given. A pixel can have any value 0 to 7. What does range of values in x-axis mean? Even though the image has 32 columns, gray value at each pixel is what matters here. Bit depth defines the range of intensity values, not the spatial coordinate. So x-axis here means intensity histogram, not the spatial x coordinate. Answer will be 0 to 7. Please bear this fully into your mind because these are very easy questions. Okay, so easy questions, easy answer. So you should always get good marks in these type of questions. Okay. Moving forward, bit depth. What is the definition? Number of bits used to represent the color or intensity of each pixel in an image. Range of values in each pixel can take. What is the range of values a pixel intensity can take? Okay. Bit depth in your 1 bit is 0 to 1, 0 or 1, 2 bit is 0 to 3, 3 bit is 0 to 7, 8 bit is 0 to 255, and 24 bit is 8 bit. Okay, 8 bit R, G, and B. So in total, you will be able to see 16.7 million colors. That is 256 into 256 into 256. Okay, resolution is what is the standard meaning of the term resolution? Resolution is the spatial size of an image, usually measured as the number of pixels in width cross height. Okay, what does it control? Amount of detail in the image. More pixel, larger image, higher is the detail. Okay, explanation. In case of example, in case of 32 by 32, it is tiny icon. Okay, in case of 1920 to 10 into 1080 pixel, it is full HD. In 3840 into 2160, this is the standard 4K HD. Similarly, 8K HD is there. So now you must be getting to know what is the exact meaning of this particular term. Okay, this multiplied by this particular resolution. Okay. Key differences: what is the meaning, what is the effect, and what are the units. Okay, intensity to color per pixel, what is the resolution, number of pixels in width cross height, and what is the color detail, then whether it is 8 bit, 4 bit, 6 bit, 16 bit. Okay, what is the thing. Then real world analogy is, imagine a grid of paint buckets. What is the resolution? How many buckets you can have? Okay. What is bit depth? How many shades of color each bucket can hold? Okay. So use wall of buckets. High resolution can be filled only with black or white, or small set of buckets can be filled with fine gradient of colors. This particular concept is very well understood if you have compared the resolution of different projective monitors of different brands, that is Samsung, then Apple, then Retina display, then OLED display. What is meant by this, that we are giving you 1.75 million colors more than this particular display. Okay, so this particular concept you will be able to much appreciate if you have compared at any store you can visit. Okay, and you try to compare what is the resolution size of different displays coming on to different laptop brands. Okay, this is the thing. Now you try to see this particular concept. Very sorry, SVD concept shifted from previous question to here. Okay, I thought that I have missed it. No, I haven't missed it. Okay, so that particular question that was left there, I promised you I will teach you SVD. Okay, singular value decomposition. Okay, so singular value decomposition is the most powerful tools in linear algebra. Okay, I'll just make a note here that this is the continuation of question number 8. Okay, continuation of question number 8. Okay, this is that particular question only in continuation. By mistake, I have pasted it here. Okay, sorry for that. But this is the continuation of question number 8. That particular question number 9 has been finished in the previous slide. Okay, yes. So now you try to see that singular value decomposition is the most powerful tool in linear algebra, widely used in computer vision, machine learning, data compression, and more of the concepts. Okay. Any real matrix of the size m by n then has been given to you, then singular value decomposition is u summation v transform. What do you mean by this? U is the orthogonal matrix, okay. Then summation is the diagonal matrix, or sigma is the diagonal matrix. Then v is the orthogonal matrix, A transform A. Previous one was A into A transform. What does it do? We shall break it into three parts. U is the rotation or reflection in the row space, summation is the stretching, and V transform is the rotation, V transform is the rotation or reflection in the column space. Okay, so all these steps, that is rotation, then scaling, and then again rotation, is performed using singular value decomposition. Okay, all three steps simultaneously are performed here. That is why it is one of the most powerful tool in the linear algebra. Okay, simple example I have taken, that we have been given a particular matrix, so SVD will give this thing, particular thing, with U summation and V transform. How it is done, we'll just see it through a detailed example. Okay, what is the application part? Application part, it is used in DLT. Okay, direct linear transform, we have just seen. Then in case of data compression, okay, I am very much confident that if it is asked in any interview, very few people will be able to appreciate this particular fact. Okay, once I was attending an interview of some particular online course, not an interview, but an examination of an online course, which was just organized by IIT Madras. And this particular question was asked there, that what particular concept is there behind the data compression? Okay. And one of the options was SVD. Okay. So singular value decomposition is that particular concept using which we keep only the top singular values and approximate with low rank matrix. Okay. So entire thing we are compressing. Okay. The white spaces and all the spaces which are non-essential, we are directly eliminating using the low rank matrices. Okay, so this particular thing is used as well as in PCA. Okay, reducing the number of dependent components. For that particular purpose also the SVD is used. Okay, solving linear systems, then pseudo inverse. Okay, this particular are the another examples. Linear systems, very complex linear systems, for example, are there in nuclear power plant power output optimization. Okay, so in that particular field, a very complex linear system is there. Okay, so that particular linear system optimization problem you would be able to solve very easily using this particular concept of SVD. Okay, singular value decomposition. Okay, this is the thing here. Then DLT in context has been given here. AH equal to 0, A equal to U summation V transform. This particular thing you have to remember. Okay. Standard, very simple denomination has been given here. Okay. So this is the summary application already I have told you. Now you try to see. We have been given a particular matrix A as 403 minus 5. Then what do you mean by these particular things? That is, I will calculate sir U, I will calculate summation, then I will calculate V transform. Okay. So A has been given as that particular matrix. 403 minus 5. Okay. Now you try to see A transform. What would be the A transform, A transpose? Okay. This you plus try to see. Okay. A transpose is nothing but exchanging the row and columns. Okay. A transpose would be 4, 0. Okay. Column wise, I am telling you. Then 3 minus 5. Then what is A transform or A transpose multiplied by A? That we will try to do. Standard procedure, row by column. Okay. Elemental wise, row by column. Then you try to see and get the final answer. This will constitute your U. Okay. Then eigenvalues of A transpose A. Determinant of this particular matrix, that is A transpose A minus lambda I, determinant of particular matrix, suppose B minus lambda I equal to 0, will give you particular lambdas when you will solve. Okay. So determinant of A transpose A we already have calculated here. Okay. This particular matrix, calculate the determinant after subtracting it to the with minus lambda I. Lambda you multiply with the identity matrix of the same order, and then you try to solve. You will get lambda as 10 and 40. Then singular values, that is sigma I is under root of lambda i's. Okay. Sigma 1 is 6.32 under root of 40. Then under root of 10 you will get as 3.16. So these go into the diagonal matrix, that is summation. Okay. Or sigma. So sigma matrix already we have calculated 6.32 and 3.16 and 0, 0. Then compute V. Okay. That is A transpose multiplied by A. For corresponding to lambda equal to 40 and lambda equal to 10. Okay. Similar to that. Okay. For both the lambdas, I'll calculate and then I'll get the V matrix. V1 and V2 are two different vectors I've got. So V transpose I'll make, then I'll get the matrix V. Okay. Then you calculate the value of U. Okay. U using Ui equal to 1 upon sigma I multiplied by A multiplied by Vi. And U1 directly you can calculate. U2 directly you can calculate, and you will get U. Now you will just calculate U summation V transform, U sigma V transform, and with the approximate values of U sigma and V transform, you directly try to multiply and get the value A. Now you try to solve Ax equal to 0, that is the last column of V, then low rank approximation you can calculate. This already I have already told. Okay. So this particular example you take and you try to calculate the entire thing step by step. Okay. Then you will be able to achieve the approximate value of A, full decomposition. That is the application of singular value decomposition. Moving to the last question of the day, consider the following 3-bit grayscale image, and you have been asked what is the value when vertical pivot operator and horizontal pivot operator are applied on this particular orange colored pixel. Okay, try to solve. Just try to see. Okay, try to copy the matrix in your notebook. Okay, then I'll explain you what is the particular mask. Everything is mask. All the operators, Sobel, Privet, Kenny, everything is mask. Okay. So that particular mask directly you will apply, and then you will be able in a position to fetch the answer. Okay. Yeah. Yes. Now you try to see, the correct option would be D, -8 and -10. Okay, no problem. We'll just see. Similar to the steps which we have followed in that particular Sobel operator question, same steps we will follow here also. Okay. We are given a 3-bit grayscale image. Values range from 0 to 7, 0143, then 2430, then 0127, then 4153. Then we have to apply the operator at value number 7, which is row 3, column 4. So 3 by 3 neighborhood, we will just see. But there is a twist here. If you will see the 3 by 3 operator, then 30 is fine, 27 is fine, 56 is fine. But what about the rest of the values? No, we cannot take 204 in this case. We'll replace that particular those particular values with 0. Okay, this pixel on the right hand side, need not to, we don't have the full 3 by 3 window on the right. To handle this, we are assuming 0 padding. Okay, that is, pad the image border with zeros. Okay, so neighborhood becomes 300, 270, and 560. Now you see what is the private operator kernels. Mask. These are horizontal GX -101, -101, -101, GY 111, 000, -1, -1, -1. Okay. Derivation of this, I know that you are very much interested. I'll bring the derivation of all the operators in the next class. Okay. Then we will discuss. Then you apply the kernel GX directly. Okay. GX directly you have to apply on this particular matrix. You don't have to perform any matrix multiplication here. One course I have taken, I think 1 year before, and the student, the copies, when I checked, I found out that the student knows the operator. Okay, but still the answer is incorrect. He is only able to get 1 mark out of 5. Okay, so what was the reason? The reason is very simple. It is not matrix multiplication. This is mask. Directly multiplication of the corresponding elements would be there. If it is matrix multiplication, then it would be row by column. Okay, that is the thing. So -1 multiplied by 3, then 0 multiplied by 0, then 1 multiplied by 0. Similar to that, -1 multiplied by 2, then 0 multiplied by 7, then 1 multiplied by 0. Then -1 multiplied by 5, then 0 multiplied by 6, then 1 multiplied by 0. So you will get GX, and similarly you will be able to appreciate or get the GY. Okay. So this is the entire thing. Okay. Final result like this. Okay, I think I am stuck. Am I connected? Okay, I'll just reshare. Okay, one slide is only left. I think the call has been cut here. Just a second, guys. Give me just a second. I'll explain you. JXGY already explained you. I'll be explaining you this particular concept. At the end, our beloved screen has left the chat. I don't know why. Just a second. I am rejoining. Yes. Now I think it is visible. Okay, screen is visible. Yes. Yeah. GXGY already we have calculated. Now what is left? Already answer is obtained. If magnitude, gradient magnitude is asked, then you just have to use the standard Manhattan formula. Okay. Under root of GX square plus under root of GY square. That you already know. Okay. It would be 12.8. We are restricting ourselves to -8 and -10 only in this particular question. Okay. So this marks the end of the 10 questions which I wanted to discuss in this particular question. The PDF of this particular presentation along with the recordings will be shared on this particular link that I already have shared. The session is end. That session has come to an end from my side. Okay. If anybody is having any doubt, then feel free to ask, or you want to suggest anything, or you want to interact, then the session is open for you. Rest, you can kindly leave. Okay, but do remember to join the session next week, same time, same link. Okay, thank you all for joining the session. The session is open for you. Okay, yes.
Thank you so much for the class,
Oh,
entire class.
okay, okay,
Next
okay.
class will be same time in same day.
Yes, yes, same time, same day next week. Just okay,
Okay, thank you so much.
okay, okay. Thank
Thank you, sir.
you. Okay, thank you so much.
Thank you, sir.
Okay,
Thank you, sir.
thank you. Thank you for joining the session. Okay. Thank you all. Thank you for joining the session. Okay. I am ending the session for you all. Okay. Thank you all.